this is a lesson on some more hyperbolic functions. So more hyperbolic functions. More hyperbolic functions. Okay. Right, before we do any of that, let's just have a little recap. So we'll do a recap. Okay, you should know, hopefully, that sec x is the same thing as 1 over cosine x. Okay, so sec x is 1 over cosine x. Cosec x is 1 over sine x. And cot x equals 1 over tan x. Okay, so we should know those as the different alternative trig ratios. Okay, so you may well have guessed what's happening now, but I'm going to say it anyway. What we're going to now is we're going to define. So we're going to define the hyperbolic sech to be 1 over the hyperbolic cosine. So sech x is 1 over cosh x. This is where it starts to get really hard to say. Cosech x. So cosech x. Well, that would be 1 over hyperbolic sine. And coth, C-O-T-H, coth x is going to be 1 over hyperbolic tangent x. Okay, so those are going to be the definitions that we're going to think about. So in terms of exponentials, 1 over cosine, 1 over cosh would be 1 over e to the x plus e to the minus x over 2. So if I simplify the fraction, I'm going to end up with 2 over e to the x plus e to the minus x. So sech x is equal to 2 over e to the x plus e to the minus x. Likewise, cosech x, well, it'd be almost the same here, except we have a minus here, so it's going to be a minus here. So that would be cosech x equals 2 over e to the x minus e to the minus x. And finally, coth x will be 1 over tan x. So that would be 1 over e to the x minus e to the minus x over e to the x plus e to the minus x. So that's saying that coth x is equal to e to the x plus e to the minus x over e to the x minus e to the minus x. And you might realize that that's the same thing as cosh x over hyperbolic sine. Okay, so essentially what we've done is we've replaced, in simple terms, we've kind of just added a h to everything, and we turn everything. All we've done is we've said that the same for hyperbolic. Okay. For the definition, that's why we've motivated the definition. Okay, so now I'm going to look at the graphs of each of these. I'm not going to look at the inverses for this lesson, but I'm just going to go for the basic graphs of sech, cosech, coth. Okay. So let's start with sech. So we've got y equals, let me write it over here actually. Suppose I want to graph y equals sech x. Right. Anytime you're looking at drawing a graph of something like this, until you remember them all off the top of your head, and to be honest, I find that tricky, it's always a good idea to think about, well, how does this relate to the one that we already know? So we know that this is going to be 1 over cosech x, isn't it? So let's draw a quick sketch of cosech again. Okay, so it's like a curve, it's going to come up here, so 1 x y. So sech x is going to be 1 over cosech x. So what we're going to do now is I'm going to look at this graph now. I'm going to divide by the values on the blue line, so you'll see. Okay, so there's one fixed point, so I'll do this in green now. If you notice here, this is 1. Well, if I do 1 divided by 1, I'm still going to get 1. Okay, so I'm still going to get 1. 1 is going to be a point that's on both graphs. The point 0, 1 is on both graphs. So the point 0, 1 is on both. Hopefully you can see that's obvious. Now then, what we're going to do is we're going to 1 divided by the value that is cosech. And the value that is cosech is the blue line here, the blue curve. So this is cosech x. So only 1 divided by this. But as you can see, this is dividing by a positive number that's increasing. So what's going to happen is, as you divide by a bigger and bigger number, your answer is going to get smaller. It's never going to reach 0, though. No matter how big a number you divide 1 by, the answer is never 0. So what's going to happen is it's going to come down like this. Oops. It's going to come down like this. But it's not going to go up at first. That's never going to rise. So it's going to come down like this, and then it's going to have an asymptote going that way. Likewise, as we're dividing by 1 divided by these values here, notice that this is going to get a really big number. It's going to come down this way. We'll try and do it a little bit better. So all I'm saying here is, if I take a point here and do 1 divided by that value, it's going to get smaller and smaller, isn't it? So this is the graph of y equals sech x. Okay. So the point on it here is 1. Okay, it's probably worthwhile having a look at how we might look at this from an exponential point of view. So I will write that now. The definition of sech x is equal to 2 over e to the x plus e to the minus x. So if we think about this way, so as x tends to positive infinity, so as x goes this way, large, what's going to happen to e to the x? Well, e to the x is going to get large. As x gets large, e to the x gets large. So that's going to go to positive infinity. What about e to the minus x? Well, as x gets large, e to the minus x tends to 0. Okay, for large x, if you think about the graph, I'll put another graph on here just as a quick sketch. This should be really in your brain, not this one by now. Let's do an e to the x very quickly. It's going to look something like that. So as x gets large, e to the x gets large. Okay, as x gets negative and large, e to the x tends to 0. So if we look at combining these facts here, this term here will go to 0. So this term here will go to 0. This term here will get very large. Doesn't ever equal infinity because infinity is not a number, but it's going to get large. So when I divide 2 by a larger number, it's going to go towards 0. So this has an asymptote, doesn't it? There's an asymptote and that's going to be the line y equals 0. So that's a basic graph of sech, hyperbolic secant. Okay. Also, probably want to mention that this value, the domain, the values that you can put in the domain, well, this is true. This can be valid for all x. We can put any real number, or alternatively, x is a real number. Okay, so we can put any value in and get a sensible answer out. It's not gonna blow up anywhere. Okay. So next one, let's have a look at cosech. Okay, so let's have a look at y equals cosech. Okay, so again, whenever we've got we want to think about a graph of something like y equals cosech, think about the graphics based on. Well, this is based on it's 1 over the hyperbolic sine, isn't it? So this is the same thing as y equals 1 over hyperbolic sine. So let's have a quick sketch of that just to remind ourselves. Hyperbolic sine kind of comes up a bit like a cubic, does something a bit like that, doesn't turn back on itself. So it goes through the origin anyway. So this is y equals hyperbolic sine x. Okay, fair enough. So how's that going to help us with the graph? Well, let's have an axis. Okay, well, first thing we probably should think about is at 0, when hyperbolic sine is 0, and it can be, it does go through the origin, 1 over 0 is not defined. So, 1 divided by 0 is simply not defined. But as we get close to 0, we're going to go really large, aren't we? Okay, so this is going to have, it's going to get, as we divide by smaller numbers, the answer will get larger. So it's going to come up like this. Okay. As we divide by ever larger numbers, the answer is going to get smaller and close to 0. So it's going to look a little bit like that. Maybe it'll be a bit more, it's kind of be quite steep down because exponentials grow really fast. Okay. On the flip side, it's going to be the exact same reflection. As we divide by a large negative number, the answer is going to get very small but negative. Okay, so it's going to come up and do something like that. Okay, so this is going to be the graph of y equals cosech x. Okay, so this has got an asymptote, hasn't it, at x equals 0. So there's an asymptote x equals 0. So actually, when we're thinking about the function cosech x, x cannot be 0. So x is a real number, but x cannot be 0. Okay, because if we did, then we would be blowing up. Okay, how might this look if we try to consider it just with the exponentials, just for completeness? So if we recall that we're going to end up with cosech x would be 2 over e to the x minus e to the minus x. So as x tends to infinity, positive, as x goes to the right, gets large to the right, so what's going to happen? So we know that e to the x will get arbitrarily larger, it will get massive. E to the minus x, well, that will tend to 0. Okay, so what's going to happen? So as we go to the right, this term here will go to 0. This term here will go to positive infinity. And so the whole thing will collapse down to 0. Okay. What about the asymptote? Well, e to the 0 is equal to e to the minus 0, and they're both equal to 1. So if x was 0, this would be 1 minus 1, which is 0. This would be 2 divided by 0, and so it would blow up. And again, you can do a similar reasoning for the case where x goes to negative infinity. Okay, what will happen then is this term will go to 0, and this one will go arbitrarily large, but it will be negative. And so we end up with our graphs. Okay, finally, let's have a look at the graph of hyperbolic tangents. Okay, Coth even, I should say. Right, so maybe we'll look at y equals Coth x. So again, start with a graph that you know. Well, we know that this graph is based on, well, it's 1 over the hyperbolic tangent of x, so perhaps we should draw that. So hyperbolic tangent has some asymptotes, has an asymptote at -1, has an asymptote at 1. Okay, what does it do? Well, something a bit like that. Okay, so these points here is 1 and this is -1, it goes through the origin. So this is y equals hyperbolic tangent of x. Okay, so let's have a graph ready of the other one. Ready for the other one. So I'll have a like this. Okay, so what's going to happen then? What's going to happen for this one then? Well, we probably should think about the asymptotes. Okay. What's going to happen with the asymptotes? So as we get large, we're going to divide them by a number that's close to 1. So in other words, it's just going to be the number itself. So just think that through. So say we had a number here, and we divided by this. Well, it's nearly 1, so it's more or less the number itself, isn't it? So as we divide by as we get farther this way, we're going to end up getting close to 1. Okay, so let's have a look at how that's going to work out. So this is going to have an asymptote at 1. And one at a -1 actually. So the graph is going to come down and do something like that. And likewise on this side. So this is y equals Coth x. This is the 1. Now notice when we're dividing by 0, we're going to have the asymptote again. So this is going to be getting closer and closer. So there's going to be an asymptote. There's going to be an asymptote here. Go. Okay, so there's going to be an asymptote this way and down this way. There we go. Okay, so this is our graph of Coth x. Let's see if we can justify this with the exponentials. So if you weren't kind of convinced by, as we go get close to 1 this way, we're dividing by a number that's basically 1. Okay, so right, let's have a look. So we're going to have e to the x so this is the hyperbolic Coth is e to the x plus e to the minus x over e to the x minus e to the minus x. So we're going to see as we go large. So as x tends to infinity, x goes to positive infinity. Well, it's a bit difficult to see what's going to happen here, but essentially these two terms would go to 0, and these two would get large, and so this is going to tend to 1. Maybe it's easier to see if I times everything by e to the x. So coth x is the same thing as e to the 2x plus 1 over e to the 2x minus 1. So as e to the x gets large, well, these two numbers are these two numbers are barely distinguishable. You can't really tell. For large numbers, like 1,000,001 and 1,000,000 are very close. 1,000,001 and 1,000,000,000 are very close. So when you divide them, you're going to get an answer close to 1. Okay, so these this way are going to go to 1. So as x tends to infinity, coth x will tend to 1. And likewise for the other one, when x tends to negative infinity, these terms here will tend to 0, and so we're going to essentially left with positive 1 divide negative 1, and so this is becoming negative 1. Okay, so I'm going to leave that for here now. We've got 3 functions: sech, cosech, coth. We've got the graphs of sech. It's valid for any real number, but it's got an asymptote y equals 0. We've got cosech, which is not, you can't have x equals 0 in the domain. You're not allowed x equals 0. It's got an asymptote at x equals 0. And finally, coth has an asymptote at x equals 0. And also that means that x can be a real number, but not 0. Okay? And the graph of it looks something like that. Okay, I'm going to do the inverses of these in a different lesson, not now.